Hello everyone, we made it to our last lesson of topic 6, lesson 6-7 on geometric sequences and series. We actually are only going to talk about geometric sequences, so we'll just go ahead and get rid of the and series part. So our learning target for today, we are going to be able to identify, write, and use geometric sequences, but not series. We will be able to construct a geometric sequence given a table, graph, or description of a relationship. We will be able to translate between geometric sequences written in recursive and explicit forms, but we will not do this last one because we're not going to do the series. Okay, so something I'd like you to add into your notes. A geometric series, you guys have learned about arithmetic sequences. Oh, I just meant to say geometric sequence. That's where you have a common difference. You are adding a number or subtracting a number. You could be adding a negative number to get to the next term in a sequence. So what makes something geometric? That's when you have a common ratio. Oops, not ratio. And that's just going to be represented by R. So instead of adding by a common difference to get to the next term, you will multiply by a common difference. So a geometric sequence uses multiplication. What I want you to have in your notes are the two different forms, because we are going to work with explicit and recursive. So let's write out the recursive definition first, because I think that's the first example we have. So a recursive definition, let's just get this in your notes and then you'll have it to refer back to as we do our examples. You always start out with your first term. That's when n equals 1. This n equals 1, n is the term number. So when it's the first term, that's your first term right there. And then the rule is you take your common ratio and you multiply it by a sub n minus 1, which is the previous term. And you do that for all the terms after 1. So that's your recursive definition. We also have an explicit definition. And remember, the main difference between these two, your recursive definition relies on the previous term, this a sub n minus 1. The explicit definition does not. That has a formula that's going to look like a sub n equals, you just take your first term times your common ratio raised to the n minus 1 power. All right, so we will take a look at a few examples and come back to these two definitions, but now you've got it in your notes.